Good morning, students. Till here we have learned theoretical paper, and today's class I will explain you about the experiments what we have to perform in this semester. Okay, in this semester you need to perform 7 experiments which includes 50 marks in your total. Okay, so experiment is of 15 marks. Okay, among that, okay, this 50 marks, you will be having one experiment given in the exam. Okay, 7 experiments you have to perform. If this situation is cleared, you can come to college and you can do as well as. But till then, we will continue on this video mode so that it will give some idea to you and lose your panicness. Okay, so number of experiments in our subject is 7. Okay, among that, the first experiment we are going to now perform is simple pendulum. Right, the experiment name is simple pendulum. So for every experiment what you have to follow is some rules. You have to maintain record. Okay, you have to write its aim, means what we are in simple pendulum, what we are calculating, whether you are finding out the errors, frequencies, oscillations, time, what we are specifying, that is regarded as aim. It means every experiment when we are performing, what we are calculating by performing it is called as aim of the experiment. Okay, so in the simple pendulum you are measuring the errors, how error is minimized, standard error, these all things what you have learned in intermediate now, that the same thing the experiment is repeated here. Okay, by simple pendulum, using simple pendulum you are measuring the errors, different types of errors, that is your aim, right? Then for performing the experiment you need some apparatus, right? You need stopwatch, you need retard stand, you need vernier calipers, you need screw gauge, right? So whatever experiments you are using, and thus here you have to write, that is apparatus. Okay, next, what formulas you are using for calculating the result should be mentioned here, that is next one, formula. Next, what procedure you are following for calculating the simple pendulum error estimation, that has to be written in 5 steps. Okay, next, tabular columns. You have to write a tabular column on that upside what you are calculating. Next, if you are having any graphs related to that, you have to write the graph. And finally, the last one is result. So these all things will include and divided by this, it is divided in this 15 marks. Okay, so now in this 50 marks, the experiment is for 30 marks. What you have to do, okay, 10 marks is for record, this is for experiment what you are doing in the exam. Next, one more 10 marks is for viva. Totally how many marks? 50 marks. It means simply by substituting you are giving record, or if you are not performing the experiment, you will not gain this 50 marks. So every semester for physics paper you are having 50 marks. Okay, so and even the externals also come from the outside. The next let us go into the experiment and discuss about what is the aim of the experiment. Okay, here see, the aim of the experiment is to determine the standard error and probable error estimations. So what do you mean by error? how it can be minimized. Like few things, even if you take to our watch itself, exactly can we read with seconds? No, right? We just say 5:15, 5:16, 5:10 like that. If you are calculating the time period with seconds, it is called as accurate. So that's why here error is nothing but is regarded as a minimizing process by repeating the oscillations, okay, repeating the oscillations and taking its mean or else average, these all things. So that is what we are performing in this experiment. So what is the aim of our experiment? Is to determine the standard error, probable error distributions according to our physical way by using some equipment. These are called as apparatus. What are those apparatus? Here is a metal bob, first one, next vernier calipers, retarded stand, thread, cork, meter, scale. Let us see what are those experiments, apparatus. See here, this is a stand with base. Okay, this is a stand with base. You can see here, this is a metal bob. This is metal bob. This is a cork. And this is thread which is used for suspension. Okay. This is retarded stand with arrangement of simple bob with a suspension of some distance away from the cork to the ground. Right? Say this. I think you have done this previously also. Okay. Now, here this metal bob, when is suspended to spring, the spring makes elastic oscillations. Now this is suspended to what? With thread. Now, what is mean position? When the bob comes to rest, it should be in rest position. Then, if you are applying some force like this, you see ma, it will oscillate like this. For one oscillation, how much of time? For 3 oscillations, how much of time? That we need to calculate with stopwatch. You know everyone about stopwatch. Even nowadays it will be available. It is available in our phones also, na? Right? So this is stopwatch. See here. If you on it, it starts moving. For particular oscillations, number of oscillations, how much we need to calculate, you have to stop it here. Again it starts from initial. If you want to calculate for 10 oscillations, you have to off it. Now what is the time period here? For me it is 7 seconds. See here. The value here is 7. Now if I want it to continue for the next one, I will do this only, on. It will continue from the second position. No, if I want to take from the first one, you have to make it to 0. And when you start the oscillations for first oscillation, then you should on it. Like this. Okay? And after how many oscillations you require, you have to simply off this. It will be off. This is stopwatch what we are using in our lab for calculating this probable errors time period. Okay. Next one is, here for retard stand we are using thread. Instead of thread, if I suspend that to a spring balance, you see here it is written spring balance. This is the weight where you can attach it. I will show how you can attach this weight. See here. Okay, I have attached the weight to the next angle. If it is not there, it shows 0. The line goes to 0. You can see here. Is it visible? Next, if you are attaching mass, its mass is changed, right? You can see here 50. Initially it was, when mass is not there, 0. When mass is attached, it is 50 grams. It means the weight of this bob is mentioned here with this spring balance as 50 grams. Okay, you can see here spring balance, grams are mentioned over there. You can also do with spring balance, right? The next one is screw gauge. So this, I think you all know very well about this screw gauge. Okay, where you can take the least values or accurate values of objects which are in spherical form, right? So this screw gauge. Here the rotations you can do with this. Here you can see the value, that is head scale, and the rotating one is pitch scale. How do we calculate the least value? I will tell you. Okay, this is the screw gauge what we are using here. The next one is about vernier calipers. Vernier calipers, I will show that. So this equipment, vernier calipers, this also you have in intermediate level. Okay, where this is main scale reading. Here from here to here, this is vernier scale reading. And how do we calculate least count? Let us discuss. This here you can see two jaws, lower jaw and upper jaw. You can calculate the length or value of particular object with up and also lower jaws and the vernier calipers. This is vernier calipers. Okay, why we are using this vernier calipers? For what purpose? In this experiment, for calculating the radius of the bob. Okay, how do we calculate the radius of the bob? Like this. Okay, keeping and between the two jaws and making tight. Okay, you will calculate the radius of the bob in this way, where you get some values coinciding with the main scale reading and the 1 year scale reading. Okay, so from this we will calculate the diameter. From diameter by 2 you will be having radius. Okay, so these are the devices or apparatus which we are using in our experiment for calculating measurements of errors of simple pendulum. Okay, so why you are saying simple pendulum? You are using here as a bob, right? The first thing which is suspended to thread, and you are making a pendulum which is in the form of which is tied to a thread and making simple oscillations. You are not taking more amplitude, right? So that's why this is regarded as simple pendulum experiment. Okay.
Breathe Clean మీ రోజువారీ
Here next we have to know what type of formulas has to be used here. The first thing, that is in tabular column. You see here, tabular column is consisting of for calculating or determining its time period. Okay, so on this time period what we have to take is first, are you able to see here, length of the pendulum suspension. Here length of the pendulum suspension ante enti, here you are suspending this thread bob, okay, to a retard stand, right, with some distance from its position like this. You are suspending this is from here to here is the length. Suppose it is 10 centimeter. Here I am considering this length of the simple pendulum is L is equal to 10 centimeters. I am writing here 10 centimeter. Unit of distance is what? Length na? So centimeter, first value. Okay. Next, time period of oscillation. It means here you are having first trial. How many oscillations? 30 oscillations, 20 oscillations, 10 also you can consider. First you have to do for trial 1, next trial 2, and you have to take the mean of this 2 as 20. 20 plus 20 it is 20, 40 by 2 you give, it gets 20. So how we will calculate this? Let us see. Okay. Now on this retard stand you are saying that you are giving some amplitude like this. Okay, you have to, is it oscillating or not? 1, 2 and fro motion is called as one oscillation. So such type of oscillations has to be carried out 30, and you have to calculate for that 30 oscillations what is the time period. Are you understanding? For the 30 oscillations made by the simple pendulum bob, okay, what is the time period noticed have to be recorded here in the first one. Similarly for the second one. Now you have to take the mean of this, will give the value of time period of oscillations, that is T value. Here what is the unit of time? It is second. So that's why here seconds. For the trial 2 it is also second. Here also seconds. Okay. The next one, period of oscillations. How we calculate is, here this is small t ma. T is equal to T by 2 will give period of oscillations. From this value if you do T by 2 you get capital T value. Next one is T square. You got the value of T here. You do squaring, you get T square value. Okay. Next, L by T square. You know the value of L na? L is equal to 10 centimeter. you substitute the 10 by t square. T square you are getting from this. You will get K value. Okay. Here what is the unit? L is centimeter. T is second square. Centimeter per second square is a unit for K. Next, if you square K, you get the value of X. Again you do X square. The table is completed. So what you have taken in this table, let us see here once again. Length of the pendulum L, time period of oscillations, you have to repeat it for 2 times and you have to take the mean. Period of oscillations, which is this T by 2, again T square. You know the value of L, substitute the value of L by T square, you get K value. If you do it square, you get X. Again the last term is X square. So in this way, we will calculate the tabular column factors L, T, T square, L by T square, X is equal to K square. Next, X square. These all things has to be written in record. I will give a PDF which is related to this experiment. You have to write in the record. When you come to college, you can collect the record and write these things in record. Practical is compulsory, which you have to do in your coursework. Okay. Next we will see how to do the experiment. Okay. Students, let us see how we have to perform the simple pendulum experiment, right? See here, already I have shown you how we are suspending a simple bob. Okay, this is simple bob. Okay, you have to wait till it's acquiring a mean position. What is mean position or rest position? It should not oscillate like this. It should not move like this. Okay, it should be constant. It should be constant like this. Okay. Now this experiment we can do even with a spring. Okay, spring attachment, and we can instead of this wire you can use, instead of this thread can we use wire? Is oscillations possible? No, it's not possible. So that's why for no error we have taken thread to be suspended here. Okay. Now when the bob has come to rest position, you have to just move this towards your right and release it. Okay. When you are releasing it, it goes here and moves like this, right? One up, one down is nothing but here 1, 2 and fro motion is regarded as one oscillation. So in the table, how we have for what we have to take the time period? For 30 oscillations. So for 30 oscillations, what is the time period? Let us calculate here for 2, 3 values. Okay, see here. This is main position. From this main position, you have to make some distance away from its main position. It is called as amplitude. Okay, this amplitude should be less. You should not give more amplitude to this bob because it will take circular rotations. So the amplitude should be less. Okay, now you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, like this, right? You have to calculate like this. So at a time you have to take the time period also. You have to calculate oscillations as well as time. So here you see here you are having, it is to be at 0. First you have to keep that to 0 and you have to on this key. Okay. Now let us oscillate this bob and calculate the time period for, now not 30, we will take for 20. Okay. Now you see here, you have to on it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Right? Now you have to on it, off it. Now you see here, what is the time? It is 27. That is trial 1. 27 seconds. So in this experiment, again what you should do, you have to remember this 27 and write it in T1 value. Okay. Now next, you have to make this to 0. 0 cheyali first, then the experiment is carried out or else repeated. Now this is main position. You have to give some amplitude and let it oscillate. See here, now on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Stop. Now you observe the same value we have got, 27. It means we just want to take a small error which we can minimize by this experiments. So now let us write those values here in the experiment and calculate the value of x, okay, by taking the measurements. You see now here, we have to calculate the distance of the bob from the retard stand from here to here. So let us calculate what is the distance from there, the center of the bob, like this, to its position. I noticed here to be 27 centimeters. It means I have taken here the oscillations for 20 with a length of suspension of bob with 27 centimeters. Okay, so you see here, so that here what is the value we have got here from the experiment, 27 centimeter. What is the value of time we have noticed? 27 seconds for the first trial. Next one, 27. Okay. The next value mean of this is what? 27 plus 27 by 2 is 27. Okay. So again, T by 2, 27 by 2. How much you get? That value you have to write here. It is almost 13, sorry, it is 13.5, right? This 13.5 square. Okay. Next, what is the L value? 27 by 13.5. Okay. Is equal to what? K. Again K square X square. This is how you complete the tabular column. So what we have discussed till here, first what is the experiment name? Simple pendulum, aim, apparatus, tabular column. Till here it is a part of the experiment. and we have noticed how the experiment has to be performed. Okay, the same experiment is repeated here for 27 centimeters, or else you can change the distance, how the rotations oscillations are taking place. The same calculations has to be repeated so that error estimation can be calculated from this experiment. In the next class we will complete this experiment.